Hello everyone. In this video, I'm explaining inverse Laplace transform. See, if Laplace transform of f of t is equal to f of s, then we call this f of t as inverse Laplace transform. So then f of t is inverse Laplace transform of this function f of s. So it is denoted as inverse transform of f of s equal to f of t. This is the given function whose Laplace transform is f of s. Then inverse transform of this function f of s is f of t. Means we have converted a function in t domain to s domain, frequency domain, time domain to frequency domain. Now we are converting back from frequency domain to time domain. So now let us write inverse Laplace transform of some standard functions. Standard functions. See, we had inverse transform. We had their Laplace transform of a constant is a by s. So inverse transform of 1 by s is equal to 1. Inverse transform of a by s is equal to a. Okay. Next, inverse transform of 1 by s minus a is e power at. Now the answer is a function of t. In earlier case, the answer was a function of s. Now, inverse transform of 1 by s plus a equal to e power minus at, and inverse transform of a by s square plus a square equal to sine at, because Laplace transform of sine at, no need to separately memorize the formula. So Laplace transform of sine at is a by s square plus a square. So inverse transform of a by s square plus a square is sine at. Similarly, inverse transform of s by s square plus a square, which is equal to cos at. Inverse transform of a by s square minus a square equal to sine hyperbolic at. Inverse transform of s by s square minus a square equal to cos hyperbolic at. Similarly, you can have inverse transform of 1 by s square plus a square, which is equal to, here in this case itself, sine at divided by a, because here a was there. Now in this case a not there means a goes to the right hand side, sine at divided by a. Similarly, you can make such changes in the standard form itself. Based on the changes, inverse transform will change accordingly. Similarly, inverse transform of 1 by s to the power n plus 1 equal to t to the power n divided by gamma of n plus 1. Because we had Laplace transform of t power n is equal to gamma of n plus 1 divided by s power n plus 1. So inverse transform of just 1 by s power n plus 1 is t power n by gamma of n plus 1. Inverse transform of 1 by s power n plus 1 equal to t to the power n divided by n factorial, where n is positive integer. In this case, gamma of n plus 1 value is n factorial. So you can write it as t power n by n factorial. These are the standard inverse Laplace transform formulae to be remembered. We'll see, for example, inverse transform of 1 by s square. So it is nothing but inverse transform of 1 by s power 1 plus 1. So that is t to the power 1 by 1. That is nothing but t. I will give more examples. Now see the first one, find inverse transform of s by s square plus 9. So as per the standard function, this is for cos. So this is cos 3t. Okay. Similarly, inverse transform of 1 by s square plus 5. See, this I can write it as inverse transform of 1 by s square plus root 5 whole square. Because we know that Laplace transform of sine at is a by s square plus a square. So this term should be as a square of some number. So I have written it like this. It should be a by, so inverse transform of multiply by root 5 this number s square plus root 5 whole square and divide by root 5. So it cancels, you are going to get the same back. Now here you can apply the formula. Inverse transform of this is 1 by root 5 into sine root 5 into t. One more, inverse transform of 1 by s to the power 3 by 2. Okay. As per the formula, this I can write it as inverse transform of 1 by s to the power 1 by 2 plus 1. So what was the formula? Inverse transform of 1 by s power n plus 1 is t to the power n by gamma of n plus 1. So this is t to the power 1 by 2, n is 1 by 2 divided by gamma of 1 by 2 plus 1. So t to the power 1 by 2 is square root of t by gamma of half plus 1 is half into gamma of half. Gamma of n plus 1 is n into gamma of n. So what is the value of gamma of half? Root pi. So this becomes, this goes to the numerator. So finally I'll write the answer here, 2 into square root of t by pi. This is because this value is square root pi here and root t here. So together root of t by pi, and this 2 goes to the numerator. Next question. Find the inverse transform of 1 by s plus 2 plus 3 by 2s plus 5 minus 4 by 3s minus 2. Okay. Now I want inverse transform. Linearity property. Linearity holds for Laplace transform. Therefore, for inverse transform also linearity property holds. Means you can split it term wise. So inverse transform of 1 by s plus 2 plus inverse transform of 3 by 2s plus 5 minus inverse transform of 4 by 3s minus 2. Now you can take the constant outside. So now it is of the form 1 by s plus a. So what is the inverse transform? E to the power, a value is 1, inverse transform of 1 by s plus a is e to the power minus 80. So e to the power minus 2t plus 3 is a constant. This I can simplify as 1 by, take 2 common, s plus 5 by 2. Okay, because we have the formula 1 by s plus a. So the coefficient of s must be 1. So 2 is there here. So 2 take it outside. Minus 4 is a constant here. Take it outside. Inverse transform of 1 by 3 common, s minus 2 by 3. Okay, let us simplify this further. E power minus t plus 3 into 3 by 2. This 1 by 2 also constant. What is Laplace inverse transform of 1 by s plus 5 by 2? It is e to the power minus 5 by 2 t. Next here minus 4 by 3. 1 by 3 is a constant. This is e to the power 1 by s minus a. Therefore e to the power 2 by 3 t. You can write it. You can keep it as it is. This is the final answer for the inverse transform of this function. So the function was in terms of yes, finally the answer is in terms of t here. The function which was in the s domain was converted to a function in the t domain. See next one, find inverse transform of this. Find inverse Laplace transform of this function. So inverse transform of 1 by s power 1 it is and root of s. So when you add the power 1 plus 1 by 2, this becomes s to the power 3 by 2 plus 3 is a constant. Inverse transform of 1 by, this is also s power 2 plus 1 by 2, s power 5 by 2. Minus 8 constant, inverse transform of 1 by s to the power half. Okay. Now let us simplify. What is inverse transform of 1 by s power 3 by 2? S power 3 by 2 can be written as 1 by s to the power 1 by 2 plus 1 plus 3 into inverse transform of 1 by s to the power 3 by 2 plus 1, and here minus 8 into 1 by s to the power. This half is written as 1 minus 1 by 2, that is minus 1 by 2 plus 1. Okay, now let us apply the formula. What is the inverse transform of 1 by s power n plus 1? T to the power n by gamma of n plus 1. So it is t to the power half divided by gamma of half plus 1 plus 3 into, this is t to the power 3 by 2 divided by gamma of 3 by 2 plus 1, and this is minus 8 into t to the power minus 1 by 2 divided by, okay, gamma of minus 1 by 2 plus 1, gamma of minus 1 by 2 plus 1. Let us simplify this further. So this is, what is gamma of half plus 1? Half into gamma of half, because the gamma of n plus 1 is property is n into gamma of n. So it is square root of t divided by, this is 1 by 2 into root pi, plus 3 into t to the power 3 by 2 divided by gamma of 3 by 2 plus 1 is 3 by 2 into gamma of 3 by 2. Again, gamma of 3 by 2, 1 by 2 plus 1, 3 by 2 into 1 by 2 into gamma of half. Gamma of half value is root pi. So it is 3 by 4 into square root of pi, minus now 8 into, this is t to the power minus half means root 1 by root t, and gamma of minus half plus 1 is gamma of half. Gamma of half value is square root of pi. Therefore, upon simplification, this goes to the numerator. 2 into square root of t by pi plus 3 cancels, 4 goes to the numerator. 4 into t to the power 3 by 2 by root pi minus 8 by root of t pi. This is the final answer. Inverse transform of this given function is this. See the next question. You have to find the inverse transform of this. Inverse transform of s plus 2 whole cube, that is a plus b whole cube formula. A cube plus b cube, 2 cube is 8 plus 3ab, 3 into s into 2 into a plus b divided by s to the power 6. So this is equal to inverse transform of s cube plus 8 plus 6s square plus 3 to the 6s plus, this is 3 to the 6s into 2, 12s divided by s to the power 6, which is inverse transform of s cube by, split it term wise, 1 by s cube plus 8 by s power 6 plus 6 by s power 4 plus 12 by s power 5. Splitting term wise and cancelling the terms. Now find the individual inverse transforms. What is inverse transform of 1 by s cube? T square divided by 2 factorial plus 8 into, this is 1 by s power 6, t power 5 by 5 factorial plus 6 constant, 1 by s power 4 inverse transform, t cube by 3 factorial plus 12 into 1 by s power 5 inverse transform, t to the power 4 by 4 factorial. Let us simplify this. This is t square by 2 plus t to the power 5 by 15. It is 5 factorial is 120 plus 6 and 3 factorial. This cancels, t cube plus 12 into t to the power 4 by 24. So t to the power 4 by 2. This is the final answer. I hope you understood how to find the inverse Laplace transform of given functions. For that, you have to remember the inverse transform of standard functions and you have to apply accordingly. Thank you for watching.